Hi friends, we are discussing electrostatic potential and the capacitor, combination of capacitors, series combination, parallel combination. Now we are going to the next topic, that is, this is 12. Potential. The next one, point 14. Energy stored in capacitor. We all know capacitor is combination of two conductors. It is conductor 1, this is conductor 2. Initially, suppose these two conductors are chargeless. There is no charge on this conductor. Then we shift from here one positive charge, or we are taking electron from here to here. We are taking electron from here to here. It means that negative charge comes on this one and positive charge comes from this one. One electron has gone from the plate 1 to plate 2. It means that 1 plus charge is created on plate 1. Now, as soon as this one is there, this will develop potential, electric field. Positive to negative field will develop. When second positive charge we deposit, this one, there will be a resistance to bring this electron to this side because of this field. Now every charge when we are taking from this second to first negative charge, it is taken here, it's plus here, plus here. And every time we bring charge, there is a position to bring that charge. Whenever there is a position, work is done. This work done is stored as energy while charging capacitor. This is the way energy is stored in the capacitor. Suppose that on this one is plus Q, on this one is minus Q. Plus Q charge deposited here, minus Q charge deposited here. We all know Q is equal to CV. C is a capacitance, B is a potential, and Q is a net charge. Let us consider in between state where charge is 2 prime. In between state we are taking when charge is Q prime and potential is B prime. Therefore, Q prime is equal to CV prime. Q prime, V prime. Q prime is equal to CV prime. Now slight charge delta Q prime. We are increasing on this one, thereby it becomes Q prime plus delta Q prime. When slight charge we are increasing, then there is a change in potential that becomes, or at constant one we are taking it. So in bringing the charge, we all know V is nothing but dW on charge. Work done on unit positive charge. Therefore, V prime is equal to dW Q prime. Delta Q we can get. So we bring it to this side. That becomes delta W is equal to V prime delta Q prime. V prime is equal to, we can write it as Q prime by C. Delta Q prime is equal to delta. So this is a small work done in bringing infinitesimal small charge delta Q prime. Now total work done W is equal to integration dW, which is equal to Q prime by C delta Q prime. Now initially the charge of 0, final charge becomes Q. Integration of Q prime delta Q prime. C is a constant, we can take it out. Q prime delta Q prime 1 upon C. Here it is Q prime square by 2. Integration of this one, lower limit, upper limit. So we get it 1 by 2C Q square minus 0. Therefore, W is equal to 1 by Q square by C. This is stored as a potential energy U, which is equal to Q square by C half. This is C square V square, that becomes CV square, which is also equal to C is equal to Q by V, so it becomes half QV. So energy stored can be given by three formulae: half Q square by C, half CV square, half QV. Now, this is the energy stored in the capacitor. Now, let us see energy stored per unit volume in the capacitor. Next point is that this is all about energy stored in the capacitor. Next point is energy stored per unit volume in the capacitor. Already we came. Next one we are saying energy density or energy stored per unit volume in the capacitor. Energy stored per unit volume. Unit volume. This is also called as energy density. We know U is equal to half Q square by C. Q is equal to sigma into A. Sigma is surface charge density, A is the surface area. Therefore, U is equal to half sigma square A square divided by C. Energy stored in capacitor is equal to. Now, C we know this one, AD, where it is the permittivity of free space, A is area of each plate, D is the distance of separation, U becomes, U is equal to half. It is C via sigma square A square epsilon 0 A, here it comes D. Now this one will cancel. It becomes half sigma square epsilon 0 A into D. AD is nothing but volume. AD is nothing but its volume. And then we can adjust it. It is a sigma square by epsilon 0 bracket square, I adjusted it. Then one epsilon 0 I give it here. It is a volume. This is nothing but energy. This is nothing but U is equal to epsilon 0. This is intensity. Sigma by epsilon 0 is electric intensity E. It's a square into, if I take it, U by V, which is energy per unit volume, which we call it as energy density, that becomes half epsilon 0 E square. So this is very important derivation. Energy density or energy stored per unit volume in the capacitor is equal to half epsilon 0 E square. It is U by V. This is important formula. Let us solve the problem from textbook, that is, let's see. I read the problem. It is 2.10. A 900 picofarad, pico means 10 raised to power minus 12. Capacitor is charged by 100 volt battery, figure 2.3a. How much electrostatic energy is stored by the capacitor? Simple one, electrostatic energy stored by the capacitor. B, the capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. What is the electrostatic energy stored in the system? We reach up to this one. Now it's given there is a figure shown. In this figure, this is, and then it's a connected to 100 volt battery. It is 900 picofarad. Energy is simple formula. Picofarad means C is given, V is given. U is equal to half CV square. This formula we can use because C and V both are given. Half CV square, which is equal to half. C is equal to 900 into minus 12. It is minus 12 into 10 raised to power 100 into 100 V square, which becomes half 9. This is 10 raised to power 10 plus 4, which becomes 4.5 into 10 raised to power minus 6 joule. It's 4.5 into 10 raised to power minus 6 joule. Energy will be stored in that one. It is coming as right. Now next this one. This is disconnected from battery. This one is disconnected from battery. And then another capacitor of equal. This is 900 picofarad. This is 900 picofarad. They are connected. This one is fully charged. Suppose that maximum charge is Q. Then charge from this one will go on this also. And charge will get divided Q by V. Charge on this one will become half charge on. When the charge on both are equal, then there is no further transfer of charge on it. As soon as charge becomes half, potential will also become half, V by Q. Both the charges. Now energy, U1 is equal to half Q1 square by C. Q1 square by C. Our energy, we all know, it is Q1 square by C. Similarly, U2. So this one will become as half Q by 2 bracket square into 1 by C, which becomes 1 by 4 Q square by C. U1. Similarly, U2 will be equal to, U2 is equal to, again, half Q2 square by C, because both the capacitors are equal. So that also becomes half. This one is 1 by 4, so 1 by 8. Square of 2 will be 4, it becomes 1 by 8. It is Q by 2 bracket square 1 by C. That also becomes 1 by 8 Q square by C. Total on system is, which is 1 by 8 Q square by C plus 1 by 8 Q square by C, which becomes 1 by 4 Q square by C. Energy was, previously if you see, energy U on the single capacitor, only on this 9 is half Q square by C. If you see this one and this one, I can write as U prime. Compare this two, you can see U minus U prime is equal to half minus 1 by 4 Q square by C, which is equal to half. So this much is loss of energy. 50% energy is lost. Actually this is energy. But then this much energy is lost there, 1 by 4. Where this energy has gone? Let us first calculate U prime. U prime is equal to 1 half into half Q square by C. Half Q square by C is this much, which is equal to half into 4.5 10 raised to power minus 6, which becomes 2.25 10 raised to power minus 6 joules. U prime together on both the capacitors, when they are charging, it is half to that of the energy on individual one. Where this half energy has gone, and this 50% energy is lost to overcome the air friction when the charges were going from one capacitor to another capacitor. The loss of energy is a 50%. This energy loss is converted into heat, and therefore, whenever the capacitors are charged, heat is generated in the surrounding medium of the capacitor. This is the reason always there is heat generated whenever we charge two capacitors. That's all for energy stored and energy dissipated while charging capacitor. Thank you.